All right, so for this first one, we are given the position vector. Oh, I guess it would be good if I turned this on. There we go. So you want to be aware of what you're given. Sometimes they give you position, sometimes they give you velocity. Very rarely do they give you acceleration. But for this one, they gave us position. So it says find the velocity vector, the acceleration vector, and an expression for speed. So first, let's find velocity. We're just going to take the derivative of what's there. So derivative of sine would be cosine, and then you're going to have to chain on a 1/2, which is actually kind of nice because why? Yeah, the 2 and the 1/2 will cancel, so it's just going to be cosine t over 2. All right, and then for the second part, almost the same thing, except derivative of cosine would be negative sine, and the 2 and the 1/2 are going to cancel. So negative sine of t over 2. And then acceleration, you're going to do the derivative of that. Again, this is almost like not new information. You just have an x of t and a y of t. So this one would be negative sine. You have to chain on a 1/2. So negative 1/2 sine t over 2. And then derivative of sine would be cosine. So negative 1/2 cosine t over 2. All right, then they said an expression for speed. So speed, and do you remember how we had this conversation about how like we have a vector, but speed is just the magnitude of that? Like speed is a scalar quantity. Remember we had that conversation. We talked about how it's like the hypotenuse of the triangle. All right, do you remember what that's going to look like? Good, gigantic square root, and then underneath. Good. It was like the one, it was like those last 2 questions on your quiz, those multiple choice ones, just like that. All right, so it's going to be this squared, so cosine squared of t over 2, because we already found the velocity. So cosine squared t over 2 plus, now when you square this, it's going to be positive. So you don't even have to write the negative if you don't want to, because when you square that, it's going to be positive. So sine squared t over 2. Now I'm going to bring up something from pre-calc that you may or may not remember. Actually, you guys, the end of your pre-calc year got wiped out, so you may have not ever learned this. But this property, sine squared of x plus cosine squared of x, does anyone know what that equals? No, you know it because you learned it. You guys have probably never seen this, but it is 1. Sine squared of x plus cosine. Oh, is that what you said? Did you say that? It comes from the Pythagorean theorem. Like on the unit circle, like your hypotenuse is 1. Anyway, when you have sine squared of an amount plus cosine squared of that exact same amount, it comes out to 1. So even though these say t over 2, they're the same thing. So this would end up being 1, and then square root of 1 is 1. So the whole thing, as messy as it looks, actually just comes out to 1. And so what that means is we have a constant speed. It's not variable. It just came out to a number, specifically 1. I feel so bad for you guys that you missed like the entire last quarter of pre-calc. I actually don't know how you made it through calculus. Yeah, like online. Oh, what a mess. All right, part B. Is the particle speeding up or slowing down at time 0? Well, neither, because we just said speed is what? Constant. But humor me while we look at it a little bit more in depth, because I want you to understand. You guys actually asked me about this at the end of last class, so this will be interesting for us to go through. All right, it says at time 0. So let's do our velocity at 0. Remember, speeding up and slowing down, you have to look at both velocity and acceleration. All right, so here's our velocity vector. If we plug in 0, cosine of 0 is 1, sine of 0 is 0. And then we're going to do acceleration at 0. So here's our acceleration vector. If we plug in 0, sine of 0 is 0. Cosine of 0 is 1 times negative 1/2 will be negative 1/2. And we're going to draw a picture of this. Again, just humor me. It's not going to take long. Let's just draw a picture. Okay. It's good review for your test anyway. I'm going to make a little table off to the side. I'm just going to do it in the margin up here where I have some space. Let's just plug in all of our quadrant angles. And you did one like practically exactly like this on your quiz. I'm just going to plug in all the quadrant angles so we can get some points. You're going to be okay. Not that much work. I think getting a visual is important. It helps you understand what's going on. All right, let's do all the X values. So we're looking right here. We're plugging into position. If you plug in 0, what do you get? 0. Oh, you know what? Actually, I just changed my mind. I forgot about this division by 2. Can I change my mind? Because I don't want to deal with that. Let's just count by pi. Sorry, I forgot. Oh, Mom, are you really that mad at me? Oh, do you have an erasable pen? Do you want whiteout? Here, hold on, I've got you. Oh, okay. Ah, you need to write in pencil for math class. I know that some people just don't like writing with pencil though, and I get that. Like it's scratchy and some people don't like that. So I do understand. I'm sorry, I forgot about the division by 2. All right, so if we plug in pi, sine of pi over 2. Sine of pi over 2? 1 times 2 is 2. I didn't want to deal with any square root of 2 over 2 or square root of 3 over 2. That's why I fixed that, right? If you plug in 2 pi, the 2's cancel, you just get pi. Sine of pi is 0 times anything is just going to be 0. If you plug in 3 pi, now you're at 3 pi over 2. That's at the bottom. Sine of that would be -1 times 2, -2, and then the last one's going to be 0. At a certain point, like it's cyclic, right? So at a certain point, you see how it's 0, 2, 0, -2. Like you remember what a sine graph looks like, okay? Now let's do this one. Cosine of 0 would be 1 times 2 is 2. If you plug in pi, pi over 2, cosine of pi over 2 is 0. If you plug in 2 pi, the 2's cancel. Cosine of pi, you're on this side of the circle now. -1, good, times 2 would be -2. Could you keep it going just based on the pattern? The next one's going to be 0 and then 2. All right, let's go ahead and graph this. When you graph them, you don't look at the t values. That's just the parameter. You're graphing x, y coordinates. So we're going to start at 0, 2. And remember, where you start matters because there's an orientation. There's a direction that it goes. So we start at 0, 2. That's right here. And then 2, 0. And then 0, -2. And so on and so forth. So you end up with a circle and your orientation is going clockwise. Let's see, we were talking about, are we speeding up or slowing down at time 0? Well, at time 0, this is where we are. That's this point right here, 0, 2. Velocity said go 1 in the x direction, 0 in the y direction. So that would be like this. And then acceleration said go nothing in the x direction, -0.5 in the y direction. Do you remember we had that conversation at the end of last block? I think was it you, Jacob, that asked me like what happens if they're at a right angle? It means constant speed, and that's what it looks like. Okay. So as the particle is moving around like this. I can't hear you. You're saying that too quietly. Oh, okay. Then I probably don't know the answer. Oh, okay. As it's going this way. As a heads up, my screen on my computer just went blank like it sometimes does. So I can't see anything here, only what's up there. So I don't know if this video is going to get recorded or not, but we'll persevere and see what happens. Okay. I just want stuff that works. You know what I mean? All right. Velocity vector of a particle is given by 2, 4. At time 0, here's where the particle is. So that's your initial condition. This one's going to be really similar to like the last one in the homework that we did. All right. So where is the particle at time 2? So let's do x first. We're starting at 2 right here. Plus, and then we want our accumulation to start at what time? 0. Good. It was actually 0 this time. And we want to go until 2. And x for our velocity was just 2. So 2 and then dt. So what's your antiderivative of just 2? Yeah, 2t x, it doesn't matter. I don't care. Pick your favorite variable, right? Such that 0 to 2. And we're going to do upper boundary minus lower boundary. So this will be 2 plus 4 minus 0, which will give you 6. All right, and then for y, where did we start for y? Like, what was our y coordinate to start out with? Yeah, this is your velocity vector, so that's kind of telling you where to go. The point where you actually started, y was 1. Go ahead. Yeah, I have it. It's right there. Yeah, and then this was upper boundary. You are correct. It's right there. Yeah, so yes, there is. It's right there. I thought for a second I forgot it too. But y started at 1. Are you guys with me on that? Like, that's where the y coordinate is. All right, plus integral 0 to 2, and then velocity for that was 4, and then dt. So that will be 1 plus, all right, antiderivative of 4 would just be 4t, such that 0 to 2. And so then it's 1 plus, and then you have upper boundary minus lower boundary. So that would be 8 minus 0. So you end up at 9. So your final answer to the whole thing is 6, 9. But again, humor me, I'm going to draw you a picture so you can visualize it. Now, if it was more complicated, you would have to do this, work it out like this. But because it's just 2 and 4, you can actually just visualize it really easily. I'm just going to draw a picture. We started at 2, 1. So we started right there. We ended up at 6, 9. So we started here and we ended up here. Look, here's why that happened. Velocity said go 2 in the x direction, and we did that twice. Why did we go 2 in the x direction twice? For 2 seconds, from 0 to 2. So we went 2 or twice. So we went 4 this way. And then the y direction, it said go 4, but we did it twice. So we went 8 that direction. So honestly, if you didn't want to work all this out, you could just go, oh, I need to add 4 on to my x. 2 plus 4 is 6. I need to add 8 on to my y. 1 plus 8 is 9. You're all just kind of staring at me, but did that make any sense? Like, okay, I'm just trying to give you another visual because I like a good right triangle. All right, what is the total distance traveled by the particle from 0 to 2? I'm going to show you 2 ways to do this as well. First thing you can do is look at the magnitude. And that's going to be that gigantic square root. Actually, it won't be so big in this case because our velocity is just numbers. It would be 2 squared plus 4 squared underneath of there. So it's going to be, well, let's see, square root of 4 plus 16. So square root of 20. So that's your magnitude. Total distance means you accumulate. So it would be from 0 to 2 of that magnitude. So you find the magnitude, and then that's what goes inside your integral. So it's accumulating from 0 to 2, square root of 20 dt. So what's your antiderivative of square root of 20? Yeah, square root of 20, whatever that is, t. Just like antiderivative of 2 was 2t. It's just square root of 20t from 0 to 2. Upper boundary minus lower boundary, it would just be 2 square root of 20. Let me simplify that. Square root of 20, do you guys remember how to split these? What's that going to split into? Yep, 4 and 5. Square root of 4 would be 2. So this would be 4 square root of 5. The other thing you could do, though, is look at this triangle. So I did upper boundary. Well, I did upper boundary minus lower boundary. I'm sorry, I didn't write minus the lower boundary because it was just 0. But it would be 2 square root of 20 minus 0 square root of 20. So just 2 square root of 20. Square root of 4 is 2, and 2 times 2 is 4. There, is that better? I'm sorry. But here's the other thing you can do. Look at this triangle. We have 4 and we have 8. What could you do that doesn't even involve calculus at all to get this distance? Yeah, do you guys like humor me here? A squared plus b squared equals c squared. So that would be what, 16 plus 64? So what's that going to be, 80? And when you split square root of 80, it'll split 16 times 5. So 4 square root of 5. You can do the problem without even any calculus. Like, isn't that cool? I don't know. You guys are like kind of shut off today, but I think that's cool. Anyway. All right, position vector. So R of t, I'll give you a break after this one because everyone's seeming very tired. All right, what was our velocity? We have to do the antiderivative of that. Where was that? 2? All right, so that antiderivative would be 2t. Here's the thing. You have to make sure that you start at the right place. When you plug in 0, you need to make sure that x is 2. Do you see that here? At time 0, that should be 2. So what do I need to add on to this to make sure that that's the case? Yep, plus 2. Good, perfect. And then for y, our antiderivative of our velocity would be 4t. Now, when you plug in 0, what should y be? 1. Good. So you'd have to put plus 1 on the end of there. All right, take like a little 2-minute break. Yeah, I'll get you all this stuff. I don't know how I'm gonna pause the video though. My screen is blank. Oh, you can? Oh, okay, good call.